So our next speaker is Jay Srinivasan. And Jay is the product manager of real device infrastructure at Google. In his past life, he is the founder and CEO of App Purify. Some of you might have heard about the name. Jay is going to talk to us about some of the challenges of optimizing performance and quality for mobile apps today.
Hi, everyone. Thanks for having me. Hi, I'm Jay Srinivasan at Google now. And App Purify, our company, was acquired by Google around 4 months ago. And before that, for the last 2.5 years or so, we've been working on automation of mobile apps on real devices for quality. My co-founder, Manish Lakhwani, was supposed to be on stage with me, but he couldn't join. My third co-founder, Pratyush, is sitting in the audience. And we're very excited to be at Google and appreciate the opportunity to talk here. I'm basically going to be using slides that I've been using for the last 2.5 years as I was selling App Purify to other folks. And the sort of interesting thing here is this slide I've not had to change in 2.5 years. 2.5 years ago, I've been saying mobile application development is broken. It's still broken, right? And it's getting better, especially folks in this audience are incredibly aware of that. But a few things so at App Purify, we probably worked with, I'd say hundreds and hundreds of mobile developers in one form or the other. And almost consistently, a few things that we saw. There was very, very limited use of continuous integration tools in mobile. It's getting better now, but it's better now, but it's still not even close to what you see in the web world. So for example, some of the top 10 apps in the iOS App Store today are still being built on one of the developers' Mac, right? There's just a lot of distance to go in terms of the use of continuous integration tools. And forget about continuous integration. I mean, if you're not even going to be able to get to automated testing if you don't think about continuous integration. So that's sort of the first thing that we see that's significantly lacking. The second thing is we find that for the most part, most mobile tools right now are poor ports of web tools or PC tools. And our premise is, look, you need to build tools for mobile quality that were built mobile first. Just like you have companies that are mobile first, the tools that you use against these companies need to be mobile first. What that results in is essentially inefficient launches. And we see this all the time. You're in a rush to actually ship your product. As a result, you're focused just on functionality. You're focused on UI. You're focused on UX. And then you ship this mobile app. And then you see all these stability issues, network issues, laggy client performance, et cetera, in the field. And then by far, and certainly, again, I want to reiterate, not this audience, because you guys are obviously very different in this. But what we're seeing, by and large, is users rely heavily, or developers rely heavily on users to actually act as their debugging layer, their test layer. So basically, you ship a product, you get all these issues in the field, and then in your next update or the update after that, you actually fix it. And obviously, what this results in is poor ratings and lost revenues. I actually think, personally, the act of shipping a solid mobile product is actually more important than shipping a solid web product, just because it's so much harder to acquire users, and you spend so much more to acquire users in the mobile space. So this is an example from my past before App Purify. And essentially, I was at a gaming company, and we launched 2 games relatively close to each other. And the graph that you see here is essentially daily active users over time. And the interesting thing is, if you look at the beginning, at day 0, you see this big spike, right? And this is classic for mobile. You basically have a launch budget. You spend all of this money getting installed. So both of these apps had very similar launch budgets. You get all of these users. Now, the difference is, obviously, over time, App 1 just started degrading, and App 2 was stable. And the interesting thing here is one of the genre of the apps, et cetera, was very similar. The main difference between these 2 apps was actually the amount of time spent on QA before the product was actually launched. And what you see at the bottom is essentially the sort of like vicious cycle that you get stuck in, right? So if you're not focused on stability, performance, and quality, 2 things are going to happen. Your existing users aren't going to come back, so you lose retention. They're going to leave bad reviews, so your ratings drop. When your ratings drop, your installs drop. When your retention drops and your installs drop, your DAUs drop. And if both of those drop, your revenue drops, right? So it's just this vicious cycle that goes on. So we've worked with a lot of mobile developers. And I think, again, none of these bullets are going to be even remotely surprising to anyone in this room. But essentially, our premise is to launch better apps, you just need to do these 4 things. You need to test and optimize on real devices and emulators. I call out emulators versus simulators, so I think you need to test on real devices and emulators. The second thing is, real devices or emulators are only 50% of the battle. Mobile, it's equally important to think about user conditions. What network is the device on? What are the other inputs that the device is going to take? Location, gyroscope, et cetera. So that's the second thing. Third thing, you're obviously not going to be able to test effectively manually, or you're just going to spend too much time, or you're going to have to hire too many people. So you have to think about how to automate. And then finally, back to like sort of reiterating point number 2, don't just focus on functionality. Look at stability, look at network performance, look at lag as well. So if I go into each of these in a bit more detail, so this is a picture of the App Purify rack right now at Google. And I'll tell you a bit more about what we're actually planning to do at Google a few slides later. But the simple premise is this. Your users are on real devices. You need to be testing on real devices. And your users are on a bunch of different real devices, so you need to be testing on a bunch of different real devices. A lot of the crash, and why I sort of emphasize real devices and emulators here versus simulators is that a lot of the issues that you're going to see are actually going to be related to the hardware itself. It's going to be related to the kernel code. It's going to be related to the amount of memory available on a device. It's going to be related to the Wi-Fi chip. So it's not just enough to test on simulators. You have to be thinking about real devices. You need to be thinking about emulators. And the cool thing is there are a lot of companies now that are actually making dedicated shared or private device clouds. So App Purify, and then as part of Google, will be doing the same. I know the Testroid folks are in the audience today. AppThwack does that. Xamarin has a test cloud coming out. There are basically a lot of resources right now to actually think about where you can find real devices to test on. And the thing is, this is only going to get more and more complex. With wearables, with more capable devices, you're now going to have to think about not just real devices, but real devices with which you can change other hardware parameters as well, like location, the accelerometer, gyroscope, et cetera. So that's number 1. The second thing is testing on real user conditions. Going back to the 2 apps that I showed you a few slides ago, where App 2 did much better than App 1, we went and did a post-mortem on these 2 apps. And what we found, so what this graph shows here is the first-time user experience. So it's the FTUI for gaming apps is very, very important. You pay someone to install the app, or you pay to get someone to install the app, and then you want to hook them in the first-time user experience. So the FTUI is incredibly important for games. And what we found when we did the postmortem is that anyone on, these are 2 carriers, and I initially had the names of the carriers, and then Google Legal told me to take them off. But on 2 carriers, basically what we found was that on 1 carrier, over the course of the FTUI, the drop went from 80% to something like 60%. That's kind of normal. It's not particularly surprising. On the other hand, in the other one, if you look at steps 4 to 5, you can see that the sort of completion rate drops from above 70 to below 60%. And so the issue as to why App 2 did so bad or App 1 did so bad was literally related to people on carrier 1 at the FTUI step 4. And specifically what happened was there was a network call that timed out on 3 bars or below on that carrier. So this is something where it had nothing to do with the content of the game. It had nothing to do with the design of the game. It had nothing to do with how many installs you bought. All it had to do with was one step in the FTUI was not tested on this carrier 3 bars or below. And that basically resulted in this game, like basically millions of dollars spent on building this game just going completely to waste. And so our point here is it's not just the real devices, it's also the real user conditions. You want to make sure that you're thinking about what are the different, so your user is going to be loading the app, getting into a subway, they're going to be getting into an elevator, they're going to have 5% battery left, they're going to get a call in the middle of playing around with your app. And you need to really think about these real user conditions in addition to the real devices themselves. The third thing, of course, and this is, I mean, it's the name of the conference, right? You have to automate. Manual testing is simply not scalable. And everyone talks about Android. Yes, Android is a nightmare in terms of the number of devices, though I think it's very addressable. But it's also iOS. If you think about it right now, you have more than 40 combinations just for iOS as well. And so you have to think about automation across both iOS and Android and Windows eventually. The second thing is you need to also test on, even if you're testing on all these different devices, let's say hypothetically you have the super rich company and you've bought every single device out there and you happen to have this army of manual testers that are ready to help you out. Even then, you got to start thinking about all the different permutations and combinations of user conditions. And basically it just gets very, very large, the space just gets very large very quickly. The other aspect, of course, is manual testing is going to miss bugs. So you can't, coverage is super hard for mobile, coverage is super, super hard for mobile automation, but even then, manual testing is just going to make it even harder. So The point, just like there are a bunch of folks providing device labs right now, I think one of the cool things about the mobile test space is there's so many great open source automation frameworks out there. This is not something you necessarily need to pay for. And at AppPurify, we probably saw 10 to 12 different frameworks used. And I think our big learning is there's no right framework that is better than any other framework. I think it really just depends on what your team is comfortable with. Some folks loved Appium. Some folks love UI automation. Some folks love Robotium. Whatever works for your team is great. The key is to actually just pick a framework and actually go with it. Now, the fourth point is this thing around functionality, right? And what you see on the pie graph on the left, so what we did, so this graph is from a year and a half ago. And what we did was we went and read every every one-star review in the iOS App Store. And we wanted to bucket these reviews into different categories. The idea was we wanted to see, look, what actually drives poor reviews? What drives poor ratings? And the blue slice, the 47%, this is what I call non-performance related. This is basically someone talking about, I don't like this game. Or my favorite is always, hey, I have a Chase account and I'm not able to log in with my Bank of America app. Right? It's just stuff that is just completely not controllable by you, which is fine. The good news about this graph is that 53% of the time someone leaves a bad review, it's actually controllable because it's related to a crash or a bug, it's related to network issues, or it's related to client-side issues. The sort of overlay on this is, as I said, we created this graph a year and a half ago. Recently, we refreshed the analysis for both the iOS and the Android App Store. And the cool thing is we actually saw the 47% drop. So I believe for Android, the 47% is actually something like 40%. For iOS, it's something like 45%. So in other words, it's, if anything, even more of the issues that people actually complain about these days are controllable by you. Now, obviously, the big thing here is crashes and bugs, and that's where the whole mobile test automation comes into play, and I'll show you some examples of that. But my big takeaway is if you just attack crashes and bugs, so functional bugs and crashes in your app, you're basically addressing every other type of, like you're addressing a space almost as large as the non-performance related ones. It's going to have a huge impact on your app's ratings. So with that said, let me actually talk about what we're going to do at Google and what we did at AppPurify. So the solution that we're working on is very similar to what we had at AppPurify, which is essentially we're going to be providing access to a real and virtual device cloud, which is going to have hundreds of real device models, essentially the hundreds of real device models and thousands of devices, in addition to virtual devices on demand. So in other words, look, you don't have to go buy every single device out there. You don't even have to go buy most devices out there. You're going to be able to access whatever devices are relevant to you, Android, iOS, as well as virtual devices. So that's the first part of it. The second thing is we're going to allow you to do extensive testing on these devices. And that consists of three components. The first is the robot app crawler. And the idea here is you don't need any test script. Maybe you need a bootstrap script to log into your app. But outside of that, it's essentially an app crawler. And we call it a robot because it's smarter than a monkey, stupider than a human. It's essentially not randomly clicking on your app. What our robot app crawler does is it dynamically detects all clickable elements on every page of your app, and it tries to crawl through your app for you. It's actually a fantastic way, without writing a single line of test code, to actually start testing your app. What you can do, and I'll show you a demo of this. What you can do is load your latest build, choose all the different devices that you're interested in, and then this app crawler is just going to start crawling through the app. One of the cool things about the app crawler, so again, we had the robot at AppPurify, as well as a bunch of different test frameworks. And I would say more than 90% of all runs that happen on the AppPurify real device infrastructure had nothing to do with the test framework. They were the robot. The reason being, obviously, mobile tests are hard to write. They're going to be brittle. You're going to have to support them. So you're very selective about what you're actually testing from a functionality perspective that you've written code for. What we find is, after a while, the tests that you've written never fail because they're the most important parts of your app, and the dev probably caught the issue themselves, et cetera. Where the crashes occur is when someone clicks on something that wasn't expected or is slightly off the beaten path. And that's what the robot is great at. So essentially, this is a great way to augment what you have in terms of your test coverage in terms of the test that you've written. This basically tries to traverse everything else in your app. Now, obviously, we're going to support test frameworks as well. our approach at AppPurify was, as I said, we did not have a preference on which test framework was the best or not. We basically wanted to support anything, because we find that anytime someone actually takes the effort to build out a test library, we want to make sure that they're enabled. And so we're taking the same exact approach at Google. We're going to be supporting every test framework. I don't think we're going to launch with all of them immediately, but there is going to be sort of a but the intent is to be completely agnostic to the test frameworks that we allow. And then the third thing is we're going to allow you to test on relevant user conditions as well. That means we're going to let you test on different networks, different carriers and signal strengths. We're going to allow you to change the location of the device, the orientation of the device, the amount of available memory of the device, et cetera. Now, it's one thing to have a bunch of devices. It's another thing to write a bunch of test cases. Now what, right? And one of the things, again, is we strongly, strongly believe that it's not just enough to know if your test failed or not. Because let's say a test failed. You still need to spend an inordinate amount of effort trying to figure out what actually caused that test to fail. And so we found something that was very important at AppPurify is to provide as much data as possible when a test actually ran. And so what we do is we'd capture video, we'd capture screenshots, all of your logs, obviously the test output, network traffic, crash reports, bug reports. All of this data will be provided to you as well. So the idea is full automation across whatever real device or virtual device that you want, with whatever test framework you want, plus plus the robot, and then a bunch of data given back to you so that when you actually want to prioritize and focus on issues, you'll be able to have the relevant data to go debug it. Now, I'm going to go through 2 more slides and then run through a quick demo. The 2 slides that I have here are real-world examples from our AppPurify days that I wanted to show. The first one is actually to demonstrate that, in our mind at least, we saw that there was a very strong correlation between crashes and ratings. So if you go back to the pie chart that I showed you, 40% of all poor ratings are crashes. So this is for an airline app. One of our customers was an airline. And they had a fairly complex development process. So what happened was they started using AppPurify, but it took them a few months to actually start integrating the issues that they saw with AppPurify into their app. But what we were able to do for them, though, is so across 8 builds, B43 to B51, what we were able to do was take every build that they shipped, run it with nothing more than the AppPurify robot on a certain set of devices, and we just wanted to catch the crash rate. So we're just trying to see if there's any correlation between crash rate. And then the ratings that the red line is, of course, the ratings, the average ratings of this app in the App Store. We literally wanted to see if there was some sort of correlation. This is just one example from this airline app, but the quick summary here is we actually found a very strong correlation between nothing more than robot finding crashes and the eventual rating that your app's on the App Store. So this is just one data point that I wanted to share with you. The second is actually, this was for a startup that basically had a productivity app. And unlike the airline, they were actually able to integrate the issues that AppPurify is finding more quickly. When they started using our product, their crash rate was at something like 50%. Now, it's not because their app was that bad. It's just they started early in the development process to actually start running our robot. Again, this is just the robot. This is not any test frameworks. Just running the robot. And literally what they were able to do was, over the course of a month, take their crash rate, at least the crashes that AppPurify could find, take it down to 0. Because it was actually very easy to do this. There was no manual effort involved. It was literally their builds continuously running on AppPurify devices. And what we do is say, hey, look, these are the crashes that we caught. They'd have the video, they'd have the crash logs, et cetera, and then they'd actually debug each of these. So the point of these 2 slides is literally to say, if nothing else, really just focus on crash. If you think about, don't worry so much about test frameworks if you haven't written a massive suite of test cases. Instead, just try to run a robot, catch crashes, and reduce it, because that's going to have a meaningful impact on your app's performance. Can we switch to the demo, please? Thank you. So this is the AppPurify dashboard. We are migrating this to be a Google dashboard with a lot more scale is probably the biggest change that's coming in the AppPurify product. And again, my point is there are a lot of other providers that provide the service too. I just wanted to show you what the AppPurify flow looks like in terms of what is something that you can do immediately. So this is our main dashboard. What we did here was these are all Android apps taken from the App Store, so that we're not necessarily telling you that one app is better than the other. These are just apps that we took from the Play Store. And taking a step back, the The best way to use a service like App Purify or any of the other services, AppTwack, TestDroid that I mentioned, is actually to use it through as part of your continuous integration system. So all of these tools have a fantastic API that you can call from your Jenkins build server. Every time you have a new build, you can push the build to these different devices, test it, get the result. So this App Purify as well is fundamentally an API. This is just a simple web wrapper that we've put on top of it. But essentially what you can do is drag and drop a new build onto the platform. And so if I were to take, for example, Pinterest, I always like to show that these are all real devices, for example, that are accessible to this account. And we don't need to go through this list. I think the only point I'd make is you want to choose a service that actually provides the latest OS versions. iOS, it needs to have iOS 8 now. Android, it needs to be supporting Android L, et cetera, right? So you want a comprehensive range of devices. You don't necessarily need to have every single device out there because nobody's using every single device. It's like the long tail is really not the issue. You want to make sure that you're hitting devices that cover around 80% of your customer space. So once you have a build, the next thing you want to do is actually have your test suite. And as I said, App Purify by default provides the Android, for Android and iOS, it provides a robot app crawler. We also allow you to add tests based on the framework that you support. We're huge fans of Appium, but it doesn't really go through this flow, but we also supported Appium and Selenium. But the idea is you can choose whatever test framework that you're interested in, choose the relevant test files. Once that test case is set up, the next thing that we allow you to do is essentially choose a combination of devices and user conditions or profiles. So what you see on the left is essentially our location network profile conditions. And so if I wanted to, for example, add a new profile, you could choose, depending on, and we're constantly updating essentially our network profiles, but you could choose like a specific carrier signal on a specific network. You could choose a specific location that you were interested in. And this device is now going to think it's on that network under that carrier condition. It's going to think it's in this location. You can then choose the devices that are relevant to you. And I don't want to clog up the entire the App Purify device pool. But basically, you can choose this combination and choose the build that you're interested in, choose the test case that you're interested in, and kick off the tests. Everything after that is our problem. Devices at scale are an absolute nightmare to manage. And we've spent a lot of time figuring out how to optimize that. That shouldn't be your headache for the most part, and so we take care of that for you. So instead, you can now see that these tests are queued. As soon as the device is ready, it'll run on those devices. Now, if I were to look at any specific result, essentially the type of data that we'd give back to you includes a few different things. Obviously, the video of the run itself on the real device. And this is a great example of the robot running through an app. As you can see, it's just trying to do random things. Nobody had to write a single line of test code, right? So this is a full video of the robot playing around with an app. The orientation changes. All that stuff happens. We give you CPU usage, memory usage, the test output, in this case, the robot output, the system log. In some cases, we capture network traffic. And the cool thing in this case is you actually have a crash as well. And so if I'm just going to skip to the results zip file that we provide. So if you actually go into this, and the cool thing is this comes back as part of the API, so you can actually have a post-processing script that basically grabs the results that come back from all the tests. And if you're just interested, for example, in crashes, just look for fatal exceptions, and then start looking through that. Or if you want a more detailed bug report, that's fine. We can provide that as well. The idea here is we're trying to provide as much data as possible from every run. So if you're focused on just crashes, great, focus on that. If you want to now start improving the CPU, decreasing the CPU usage of your app, that data is available here as well, and you know what to focus on. But the point here is you want to choose a service that has automation on as many devices as possible. Again, it's not about the, and there's a limit to this, right? You don't need every single device out there. You probably want to talk about the top 60 to 80 devices. You really want to think about real user conditions because that's almost as important as the real devices or virtual devices themselves. And once you're running these things, it's not enough to just look at the test output. You want to make sure that you're looking at all this other data as well because that's what's actually going to help you fix the issue. So if we can go back to the presentation, please. So that's all I had. If anybody has any questions, please drop a note to lakwani@google.com or jsrinivasan@google.com. I believe our App Purify addresses work as well. So j@appurify.com as well. Happy to tell you more about this. Can give you a better sense of the timeline of when we'll be launching our Google service. And we will be doing a sort of limited beta soon. And if anybody's interested in participating in that, we'd be more than happy to accommodate you as well. Thank you.
Thank you, Jay.
So I have another question from the moderator. How do you ensure the video and log capture, test harnesses, robot agents, et cetera, don't adversely affect the app under test? Like the app only crashes when there's a screen capture process happening.
It's a great question and something that we basically spent 2.5 years on. So obviously, all of the background processes, et cetera, that are running to capture this data do have an impact on the app. We took a principle of saying the CPU impact from any of our tools shouldn't be greater than 5% of a recent device, and I think it's no more than 5% of an iPhone 5, for example, in iOS. We wanted to make sure that RAM usage was no more than something like 40 MB. So just at least in terms of performance footprint, we did a pretty good job. In terms of crashes, like how do you know that our platform is not causing a crash? It's a great question. And it's basically, we've been running thousands and thousands of runs over the course of the last 2.5 years. So when there were crashes caused by us, we fixed it. So by and large, so what you'd be able to do is look at the logs and see if it's our platform creating the crash or if the app actually crashed. I have nothing better than my word to say, look, we've caught almost we haven't seen any issues caused by our platform themselves. There are occasionally situations where our platform is writing to the same part of the phone as your app, and that causes contention, causing a crash. That happens occasionally, but usually when we find those types of issues, we fix it in our platform. So it's basically through experience, we've gotten really good at making sure we're not having an impact.
So I have a question. So when you talked about the robot, can you give us some information about how do you measure what it covers in terms of the exploration space? Do you have any information about what it covers?
So at the simplest level, when possible, if we can detect what the UI view or UI web view looks like, we basically look at that and then basically create a tree based on each link in the view. So essentially, we're not really focused on the screen size. We're just focused on what's clickable and what's not. If it's OpenGL or if there is nothing clickable, et cetera, at that point it defaults to being a monkey. At which point it's essentially a function of the size of the screen. The thing about the robot is what happens, for example, if so we throw in swipes, we throw in rotations, we try to lock the screen, we can turn off Wi-Fi, turn it on, stuff like that. So what if the robot swipes down on an Android phone and turns off Wi-Fi? That's happened. So then we basically built a bunch of things in the robot that, if that happens, comes back to the app and turns Wi-Fi back on. So the basic principle of the robot is clickable elements in the app and trying to iterate through it, but there are like a bunch of catches around that make sure that it actually stays on the app.
So when you actually find a crash in the application, do you get some sort of, here are the minimal reproducible steps, or you're just going to have to watch through the video yourself? And even better, if you do get some sort of reproducible steps in a log file, can you just do that locally? So you can just like paste it into your, in the ideal world, local app crawler at your...
Great question. Let me tell you what the eventual goal is. The eventual goal is to keep shrinking the steps that the robot does until it localizes the crash. That's like a distant dream, may or may not happen. What we do right now, though, is we have a seed for every run of the robot. So you can at least reproduce the exact same sequence that the robot... So first of all, in the output log, you'll see the steps that the robot took. You'll see the video, the system logs, the network traffic. Obviously, everything is time-stamped. So from a time perspective, you know exactly what was going on, so you can try to reproduce it locally. The robot also has a seed value, so you can you can pass that in through the API and say, look, I want to run the robot with this seed over and over again to see if the crash is reproducible. But honestly, most of the time, the best way to do it is actually to look at the video, see if there's something obvious in the logs, and if not, then start fiddling around.
So how long is a typical run? Is like 2 hours and then
it's up to you. So like we've actually been doing, so we're trying to do some stuff at Google where we just start running robot on a bunch of different apps. And for that, we want to make sure that we capture all the relevant data in as short a run as possible. So we've been running a bunch of experiments where we've been trying, so we've taken 100 apps, and we're trying to see, look, what are the different robot tests? So the robot length is configurable. You can choose whatever you want. But what is, the question that we've been trying to answer is, what is the minimum length such that you get the majority of crashes? And we found that that length is around 10 minutes.
Nice.
So you can run it for 5 minutes, but we actually find that 5 minutes isn't great for crashes.
But do you do any like steps that aren't optically visible easily on a screen, like turn on
No,
and off
everything is a UI
Wi-Fi,
step.
which is kind of subtle, I guess. If
Everything is
you're
a UI step.
Oh, yeah, cool. Oh, thank you.
Thank you.